Section 3.4 measures of relative standing or position. A z-score is a way that we compare something or someone to the rest of the group. Okay? For example, Michael Jordan and Rebecca Lobo are both former NBA players. Rebecca Lobo is a former women's NBA player. She's now does commentary. Both are very tall compared to other people. How much taller are they than others? Since the average woman's height is lower than the average man's height, we're going to do what's called standardizing the values. This means compare apples to apples. This means we're going to compare something to the average for its group. It wouldn't be fair to compare a 10-year-old girl's height to an adult male's height. Okay, you only compare things to the average for that group. So we're going to compare Michael Jordan's height to the average for men. We're going to compare Rebecca Lobo's height to the average woman. Okay, and I've got some pictures that are going to be posted in the modules with this lesson, just so you can see Rebecca Lobo. I'm sure you know who Michael Jordan is. Okay, men have a mean height of 69 inches with a standard deviation of 2.8. Remember, the standard deviation measures the variance. Okay, are the numbers close together? Do most men close to the average, or is there a large range? Michael Jordan is 78 inches tall. Women have a mean height of 63.6 inches, standard deviation of 2.5. So we can see that women's height, the average is lower than men, and also a lower standard deviation. That means there's less variation. Okay, Rebecca Lobo is 76 inches tall. We're going to compute their z-scores. We're calling Michael Jordan MJ and Rebecca Lobo is going to be RL. Okay, so I don't have to type out their names over. Okay, the formula for a z-score is x minus mu over sigma. Mu, the curly looking M, is the mean. The thing that kind of looks like a curly R is the standard deviation. We're going to take the number and subtract the mean. On your calculator, hit enter or equals so that it does the subtraction. Then divide by the standard deviation. We're going to round to hundreds. Okay, so let's find the z-score for both of these people. MJ, Michael Jordan, it said he was 78 inches tall. Subtract. We're going to use the mean for men, which was 69. Divide by the standard deviation for men, which is 2.8. Okay, we're still on MJ. 78 minus 69 equals 9. Then divide that by 2.8. That equals 3.2142857. We're going to round to hundreds. Okay, the hundreds is the second place value. Okay, the second place value is a 1. Let's look to the right. There's a 4. So that 1 stays. So Michael Jordan's z-score is 3.21. Okay, Rebecca Lobo, her height is 76. Subtract the mean. She's female, so we're going to compare her to female. Women have a mean height of 63.6. Divide by women's standard deviation, 2.5. Okay, this comes from up above in the paragraph. Okay, we're on RL. 76 minus 63.6 is 12.4. Divide that by the 2.5 equals 4.96. Okay, hers divided a little nicer, the number, so it was already rounded. So Rebecca Lobo, z equals 4.96. Okay, what does this mean? Michael Jordan's height is 78. Hers is 76 in inches. He's taller than she is, but her z-score is higher. Her z-score was larger, 4.96. What does this mean? When you compare Rebecca to the average female, her height is more extreme from the average. Okay, it is a more extreme away from the average. Okay, let's convert both of them to feet and inches. There's 12 inches in 1 foot. Okay, 12 times 5 equals 60. That means somebody that's 5 feet tall, 5 times 12 is 60, would be somebody that's 5 feet tall is 60 inches. Okay, what about 6 feet tall? 12 times 6 equals 72. So somebody that is 72 inches tall is exactly 6 feet. MJ and RL have heights both larger than 72. Okay, so for MJ, he's 78. 78 minus 72 is 6. So that is the 6 inches left over. So MJ is 6'6". Okay, let's go over that again. There's 12 inches in 1 foot. 12 times 6 is 72. So somebody that is 72 inches tall is exactly 6 feet. But MJ and RL are both higher than 72. Okay, Michael Jordan is 78. So 78 minus the 72 means an extra 6 inches. 72 inches is 6 feet tall. So 78 minus 72 means Michael is 6'6". RL is 76. 76 minus 72 is 4. So that means RL is 6 feet 4 inches. Okay, now if they're both standing side by side, Michael Jordan is taller. 78 is bigger than 76. Okay, what would surprise you more? A woman that was 6'4" or a man that was 6'4"? The woman that's 6'4" is more surprising because it is more extreme. Okay, because it's more extreme. Z-scores compare one thing to the average for the group. Is it close to the average or extreme? Extremely higher or extremely lower? You may do this if you take a test and then the teacher gives the test back and tells you what the class average was. Okay, you may compare your score to the average to see if it's higher or lower. Okay, so a Z-score compares something to the average. So the 4.96 was bigger than 3.21. So that means Rebecca's height was more extreme in relation to the average. Okay, some more examples. Okay, the average height for men is 69 inches. Convert that to feet and inches. There's 12 inches in 1 foot. 5 times 12 is 60. So somebody that's 5 feet tall is 60 inches. So 69 inches is 5'9", because 69 minus 60 is 9. So the average for men is 5'9". Does this mean a man is 5'10" is extremely tall? No, that's just a little bit more. 5'8", that's not extremely short because that's just a little less than average. Okay, extreme or unusual values are things that are very different. If the average is 5'9", then 5'10" and 5'8" are just a little bit away from that. Extreme or unusual values are things that are very far away from average. Mathematically, we determine if something is very far from average by its Z-score. Things that are considered usual for a Z-score is if it's between -2 and +2. Unusual values are things that do not fall in that range. So if Z is bigger than 2 or less than 2. Any Z-score that's more than 2 is unusual, or anything that's less than -2 is also unusual. Okay, oops, sorry. Let's talk about Muggsy Bogues. He's a former NBA player, and on in Canvas I've got a picture of him. Muggsy was 5'3", a former NBA player. He is being known for being one of the shortest. Is his height usual or unusual? So we're going to compare him to the average man. First, we need to take Muggsy's height and change it to inches. 12 inches in 1 foot. He is 5'3". Okay, so 5 times 12 equals 60. Now add the other 3 because he's 5'3". Okay, somebody that's 5 feet tall is 60 inches, but he's 5'3", so 60 plus 3 is 63. Okay, so what's Muggsy's Z-score? His height is 63, subtract the average for male 69 divided by the standard deviation of 2.8. So 63 minus 69 is negative 6 divided by 2.8 and round to hundredths. The hundredths is the 4, that's second place. To the right of 4 is 2, so the 4 stays. So this is just barely unusual because it's just barely less than negative 2. But when you look at them, it looks like an extreme difference, okay? But it's just barely unusual. That's because when we see Muggsy, or when he used to play in the NBA, we'd see him with standing by other NBA players, so it looked very extreme because you were comparing him to other NBA players visually, okay, which are usually taller than average. Okay, what do you think would happen if we compared him to the average for all men? That shouldn't say all men. Okay, I'm going to correct it on the handout. For all NBA players, it would be more extreme. If you compared him to all NBA players, it would be more extreme. Okay, so a z-score is found by taking a number and subtracting the mean. If the first number is smaller than the second number, it'll be negative. So this would be when the number's lower than average. If you subtract and get a negative, that's because the first number is smaller. What if you subtract and get a positive? That's when the first number's bigger than the second. This would be if something's higher than average. If you subtract and you get 0, that's because the two numbers were the same. So if the first number and the second number are the same, you'll get 0. So that means something's exactly average. So if a z-score is negative, it's below average. If a z-score is positive, it's above average. 0 means something's exactly average. Okay, so some more examples. On standard IQ's test, the mean IQ is 100, standard deviation is 15. On the game show called The Chase, there's a man with an IQ of 150. Compute his z-score. Okay, and there's a picture of him in there as well. Okay, solution, we take the number, subtract the mean, divide by the standard deviation. So his IQ was 150, subtract the mean of 100, divide. 150 minus 100 is 50. Divide, we get 3.33. Rounded is 3.33. This is unusually high since it's bigger than the 2. The range is -2 to 2 to be usual from up above. Okay, more examples. A police chief takes a certain precinct and finds the average number of tickets. The mean is 4, standard deviation is 2. An officer writes 7 tickets. Let's see if that's usual or unusual. Okay, the officer wrote 7 minus the mean is 4, divide by the standard deviation. Okay, same formula. You take the number minus the mean, divide by standard deviation. 7 minus 4 is 3, divided by 2 is 1.5. This is higher than average, but it's still usual because it's between -2 and 2. Between -2 and 2 is usual. Okay, so that officer wrote higher than average, but not extremely. Okay, just some more examples. Full-term babies have a mean weight of 7.5 pounds, standard deviation of 1.25. My son Chase weighed 9 pounds and 10 ounces. What's his z-score, usual or unusual? First, we have to change that to decimal. 9 pounds, 10 ounces is not 9.10. Okay, 9.10 means 10 out of 100. Like $9.10 is 10 out of 100 cents. Okay, it's not 10 ounces out of 100 ounces, so it's not 9.10. Okay, how do you find the decimal? There are 16 ounces in a pound. Okay, the 10 ounces out of 16 ounces divide is 0.625. Okay, 10 ounces out of 16 is 0.625 of a pound. So his weight was 9.625 pounds, changed to a decimal. So take his weight, subtract the mean, 7.5, divide by 1.25, and you get 1.7. Okay. It is higher than average, but not unusually high, since it's between -2 and 2. Okay, so that would be usual. Okay, same data, but with my daughter's weight. She weighed 6 pounds and 14 ounces. What's her Z-score? First, change her weight to pounds. 16 ounces in a pound, 14 ounces out of 16 gives 0.875. Okay, 14 ounces is almost another whole pound. 6 pounds, 14 ounces, that was almost 7 pounds. So her weight was 6.875 pounds, changed to a decimal. So her weight minus the 7.5, that's the mean, divide by the 1.25. So her Z-score comes out to -0.50, which is lower than average, but not unusual. Okay, so it is usual. It's between -2 and 2. Okay, what about the mean pulse rate, resting pulse rate for women? 72.9 beats per minute, standard deviation. What's the Z-score for somebody whose resting pulse is 99? Okay, so same formula as above. We take 99, we subtract the mean of 72.9, divide by the standard deviation, and round to hundredths. The 2 that's in the hundredths has a 1 to the right, so it stays 2.12. So this is unusual since it's larger than 2. Okay, so this person has an unusually high resting pulse rate. Okay, babies born in a gestation period between 32 and 35 weeks have a mean weight of 2,800 grams, standard deviation 900. Babies born after 40 weeks have a mean weight of 3,300 grams, standard deviation 455. Okay, a 33-week gestation period baby weighed 3,250, and a 40-week period baby weighed 3,750 grams. Find the Z-scores for each of them. Which baby weighs more relative to the average? Okay, so let's take the 33-week baby that weighed 3,250. Use the mean and standard deviation for babies that are between 32 and 35. Okay, so for the 33-week baby that weighed 3,250, so take 3,250 minus the mean for this group was 2,800, and the standard deviation for this group is 900. Okay, it wouldn't be fair to compare a baby that was 33 weeks to one that was 40 weeks, comparing it to the average for that group. Okay, subtract and divide, and you get 0.50. Now let's look at the 40-week baby that weighed 3,750. Okay, so you use the mean and standard deviation for 40-week babies. So this baby's 3,750 minus the mean for this group was 3,300. Divide by the standard deviation for this group, and we get 0.989, and all of those rounded to 2 places is 0.99. Okay, so let's go back and compare the two. The first one's 0.50. The second one was 0.99. The first Z, 0.50. The second one, 0.99. So the second one, that Z-score is higher. So what does that mean? The 40-week baby weighs more relative to the average because the Z-score was higher. Okay, it doesn't have anything to do with The actual weights, it has to do with the z-scores because we're comparing it to the average for the group. Okay, that is the end of this lesson.